P negative 4, 3 is a terminal point on angle theta in standard position. To the nearest tenth of a radian, determine possible values of theta in the domain from negative 2 pi to 2 pi. When you read this question, the first, almost all of it, should have sounded like, hey, we've done a question like this before. The only thing different was the last symbols. Instead of saying from negative 360 degrees to 360 degrees, this question is now in radians and saying negative 2 pi to 2 pi. Which means we will do everything identical to the way that we did it before in degrees. The only thing we have to do is change our calculator to radians and think in radians to get our answer. So what does that mean? Well, when we had this question before, you might have drawn a picture. You would have thought of negative 4, comma 3. That's a point here in quadrant 2. So if that's an angle in standard position, there's our angle theta. What kind of question is this? How do we solve trig questions? It's a triangle question. And triangle questions always involve drawing your triangle, here it is, in purple, to your nearest x-axis so that you have your reference angle involved. What do we know about this triangle? We know that this length is 4, this length is 3. Ooh. What's the other length? 5. Did you do a squared plus b squared equals c squared, or did you know it? As a special triangle where all the sides are nice. Okay, remind me to get off topic about nice triangles after we're done this question. But not now, because we should focus. So you've got your triangle, 3, 4, 5, and you want to find the angle theta. Well, in order to find the angle theta, we're first going to find the reference angle. And with that reference angle, okay, we have a triangle. You go back to your basic trigonometry from grade 10. You could set up the fact, hey, I know that tan of my reference angle is opposite over adjacent is 3/4. And so my reference angle is what? Now, in previous questions, you would have gone to your calculator, and your calculator would have been in degrees, and you would have done tan inverse of 3 divided by 4 and got my angle is 36.9 degrees. But now, since we're dealing in radians, we should have our calculator in radians and go tan inverse of 3 divided by 4, and we get 0.64. And it's going to feel a little bit weird when we write our answer here, 0.64 for our reference angle. Does it look like 0.64? Okay. Again, you don't really have a feel for radians yet. If I drew that and I said, does it look like 36 degrees, 37 degrees? You'd be like, yeah, I can see it. But 0.64? Not yet. Okay? But we have our reference angle. Now, we want to find what theta is. And when it's going from negative 2 pi to 2 pi, that means we need to find one answer in the positive direction from 0 to 360 or 0 to 2 pi. And once in the negative direction, I'll draw the negative direction one in red, from 0 to negative 2 pi. If you were doing degrees, would you agree that this green one, you would do 180 minus your reference angle? But now we're dealing in radians. What would we use instead of 180? Instead of 180 degrees, what's halfway around the circle in radians? pi. So for our green angle, we will say it's going to be pi minus my reference angle, which, if I go to my calculator again, some things that are sometimes helpful with a reference angle, because we're going to use our reference angle more than once. If you have the ability on your calculator to store or to keep it in memory, on this calculator I can store it as x. Then it keeps it as in memory that that's x. How did I say I was going to find my angle? Pi minus my reference angle. So I can go pi minus, and instead of retyping all of that, I can just go x because it stored that value, and I get 2.5 to the nearest tenth, 2.5. And for my red angle, this is another example of what theta could be. For my red angle, what would I normally do if this was degrees? I would probably go pi plus my reference angle and make it negative because I'm going in the negative direction. I would do 180 plus my reference angle, find out what that number is, and then just make it negative. So if I'm working in radians, I'll do the same thing. I'll go pi plus my reference angle, and whatever number I get, I'll just make it negative because I'm going in the negative direction. So again, this is where it's nice that I've already stored my reference angle as x. You can go pi plus x, push enter, 3.8. Negative 3.8. And now we've solved for theta in between negative 2 pi and 2 pi. Since standard angles always start from your positive x-axis, whenever they give me a domain from negative 2 pi to 2 pi, I instead break it up into positive angles and negative angles. My positive angles would start at 0 and go to 2 pi. My negative angles would start at 0 and go to negative 2 pi. So if I want to find all the answers in here, I'm really thinking I'm looking for positive angles between 0 and 2 pi, or 0 and 360 degrees, and negative angles between 0 and negative 2 pi, which would be like between 0 and negative 360 degrees. An added confusing thing about radians. Notice how we wrote our answers. Theta equals 2.5 and theta equals negative 3.8. In degrees, you always have to add a degree symbol. Radians is the only units that I know of that has no symbol for units. So you don't have to write any symbol, or you don't have to write radians. If you write an angle just as a number, it means radians. So your teachers in the past, when you just knew degrees and you said the answer was 30 and you forgot the degree sign, technically to that math teacher you wrote 30 radians because you didn't include a unit, which is not what you meant because you had no idea what a radian was. So your teachers were like, you have to include the units. And now we have the first thing ever that doesn't have units. I know a math teacher in another school that bugged him so much he invented his own radian unit by putting a degree sign with an R inside of it. But it doesn't exist. But we have to make sure that we understand this. The result of this causes some confusion because you will hear people talk without units. Right? I did here. I said the angle is 2.5. I should probably still talk about saying the angle is 2.5 radians. But we get into that habit of just saying the number. Right? you will hear me say, and again, I'm partially at fault for this. Okay, this is true. 180 degrees is equal to pi radians. But then you will hear people say pi equals 180. That's not true. Pi is 3.14. Dot, 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 dot. Pi is always 3.14. Pi radians is equal to 180 degrees. That's true. But pi is not equal to 180. But you will hear people say this, and we're forgetting the degrees or the units. Is 12 equal to 1? No. But 12 inches is equal to 1 foot. If you add the units, it makes sense. If you don't, it doesn't make sense. So just something to think about and be aware. Okay, part B. Given cotangent of theta equals -2, determine the values of theta between -2 pi and 2 pi. Okay, I'm just going to erase this to get some white space. Okay, again, it's a triangle question. We want to find where is this triangle so we can find the values of theta in standard position. Whenever you have one of your reciprocal trig functions, here we have cotangent, the first thing you'd like to do is think about what does tangent equal? If cotangent is -2, since we're thinking about the ratio, tangent will be the reciprocal. It's going to be 1 over -2. Next, we're going to draw a triangle. In this case, we're going to draw 2 triangles. What quadrants is theta going to be in? How do I know it's here? With this being my reference angle, and tangent is opposite over adjacent. I can label that as 1 over 2. How did I know quadrant 2? And how do I know that the other quadrant has to be in quadrant 4? Again, here's my reference angle, 1 over 2. Those are the quadrants where tan is negative. According to the cast rule, tan is positive here and here, negative here and there. Since tan is -1/2, it's going to exist in quadrants 2 and quadrants 4. Once you've drawn your triangles, could you find that reference angle? Again, when you're finding a reference angle, because you're dealing with an actual triangle, your ratio is always positive. Because we're thinking about actual lengths. That length is 1, that length is 2. We're not worried about the fact, oh, but you went 2 to the left. Should you label this as a -2? No. All positive values when thinking about reference angles. Go to our calculator. Again, we're in radians, so we make sure our calculator is set in radians. And we can go tan inverse 1 divided by 2. Reference angle of 0.464. If that's my reference angle, I need to find all the values of theta between -2 pi and 2 pi. Again, just like before, check this out. I think that's, I think 0 to 2 pi and 0 to negative 2 pi is what I wrote before when I have positive and negative angles in my domain. I'll draw my positive angles in green. If I start at 0, this will be one answer for theta. This will be another answer for theta. If I'm going in the negative direction, this will be one answer for theta. This will be another answer for theta. Again, the ideas for these are identical to how we did them with degrees. In degrees, if I wanted to find that first answer in quadrant 2, maybe I'll just put quadrant 2 out in front, dot, dot. What's theta going to equal? In degrees, I would do 180 minus my reference angle. In radians, I would do pi minus my reference angle. So again, I'm going to go to my calculator. I'm going to use that reference angle a lot. So I'm going to store it as x so that it remembers it. And here I can do pi minus my reference angle, 2.68. Did it say to the nearest tenth? Yes, it does. 2.7. In quadrant 4, if I was doing degrees, I would do 360 degrees minus my reference angle. Now that I'm working in radians, I would do 2 pi, because that's 360 degrees, minus my reference angle. Again, go to my calculator. 2 pi minus my reference angle, which I've stored as x, 5.8. Now for my negative angles, for my negative angle in quadrant 2, what's theta going to equal? Well, if I was thinking in degrees, I would go 180 plus my reference angle. So in radians, I would do pi plus my reference angle. Whatever answer I get, I'm going to make negative because it's a negative angle. So I'll go to my calculator. Pi plus my reference angle, 3.6. So whatever answer I got will be negative 3.6 radians. And finally, in quadrant 4, if I was dealing in degrees, I'd say, hey, my answer is going to be exactly the same as my reference angle, just negative. So in this case, my reference angle was 0.46, rounded to the nearest tenth, 0.5. And so we get 4 answers for theta between negative 2 pi and 2 pi. Usually with the cast rule, you have an angle in 2 different quadrants. So between 0 and 2 pi, you get 2 answers. In this case, we went from negative 2 pi to 2 pi, so we got 4 answers. Of all the questions we've done today, these triangle questions probably come up the most. So I'll get you to do questions 13 and 14 right now. And then I'll get back to how I wanted to get distracted by nice triangles. This is more important. I'll get you to work on this, and then when we get to like the last 5-10 minutes, I'll share some interesting stuff with nice triangles.